Warrior 1 and Warrior 2 are just two examples that emphasize the critical role of space probes in expanding our understanding of the universe. These extraordinary spacecraft act as our eyes and ears in space, venturing into territories far beyond our reach and providing us with real-time data about our solar system through their instruments and sensors. They relay information that helps scientists study cosmic phenomena from a distance, overcoming the limitations that prevent direct exploration. For many years, these probes have been essential tools in our quest to learn more about space, giving us insights we otherwise couldn't obtain. Recently, however, Voyager 1, one of NASA's most iconic space probes, has been sending back strange data from deep space, which has raised concerns among NASA engineers. They've begun to question whether Voyager 1 is encountering something unknown, or if there's an issue with its systems. Could these signals represent an unusual message from deep space? Or is there another explanation? This mystery has prompted further investigation, leading us to explore how Voyager 1 has been influenced by mysterious forces beyond the familiar regions of space. For nearly 45 years, the Voyager missions have been at the forefront of space exploration, providing some of the first and most significant observations of our solar system. Launched in 1977, NASA's twin Voyager spacecraft, Voyager 1 and Voyager 2, were designed as exploratory missions to visit the outer planets of our solar system. These spacecraft are incredible in their longevity and performance, serving as time capsules from a different technological era. Each Voyager probe is equipped with an 8-track tape recorder, a technology that by today's standards is ancient and vastly inferior in terms of storage capacity. For comparison, the data storage on the spacecraft is billions of times smaller than that of modern smartphones. Even more astonishing is that the Voyagers transmit information at a speed that is up to 38,000 times slower than the internet connections we use today. Despite these limitations, both Voyager 1 and 2 have continued their journey through space long after completing their initial missions, and are now the only human-made objects to have ventured beyond our solar system into interstellar space. Their ongoing mission is to traverse the vast and largely uncharted regions of space, collecting data that gives scientists a unique perspective on the boundaries of our solar system and its interactions with the greater cosmos. Their journey has allowed us to observe the interactions between the solar wind and the interstellar medium, providing scientists with unprecedented data for comparison between early and more recent observations. No other spacecraft has had as significant an impact on our understanding of the Sun and its role in shaping the space environment as the Voyager missions. They've revolutionized the way we see our solar system, but their contributions go beyond just scientific data. Each Voyager spacecraft serves as an ambassador for humanity, carrying with it a golden record, an iconic artifact intended to represent the diverse culture and knowledge of Earth. These records contain music, greetings in various languages, and images that showcase life on Earth, as well as diagrams explaining fundamental scientific principles. These messages were designed with the idea that if any intelligent extraterrestrial life were to encounter the spacecraft, they would have a glimpse into who we are as a species. The gold coating on the records is specially designed to withstand the harsh environment of space, ensuring that these records could survive for over 1 billion years, remaining intact even as the Voyagers drift further away from our planet. In many ways, these records are like cosmic time capsules or messages in a bottle, floating through space with the hope of reaching another civilization. Scientists have been surprised by some of the findings sent back by the Voyagers, especially regarding the interstellar magnetic field. The data collected has sparked debates among experts, particularly about the shape and behavior of the heliosphere, which is the magnetic bubble created by the Sun that surrounds and protects our solar system from the interstellar medium. For a long time, the heliosphere was thought to be comet-shaped with a long tail extending behind it. However, new observations suggest that it may be more spherical than previously assumed. This discovery has raised new questions about whether the heliosphere changes in response to the Sun's activity, such as the appearance and disappearance of sunspots, or if it remains relatively constant over time. As the Voyagers continue to explore beyond the heliosphere, they are providing crucial clues that help scientists piece together this complex puzzle. The boundary between the solar wind and the interstellar medium, known as the heliopause, is another area of great scientific interest. The solar wind consists of charged particles emitted by the Sun, which stream out into space, forming a protective bubble around the solar system. However, this bubble eventually gives way to the cooler, denser plasma of the interstellar medium, the space between stars. Much like how Earth's atmosphere has layers and boundaries, the solar system has its own distinct layers, with the heliopause marking the outermost edge. When Voyager was launched, scientists were unsure how far this boundary extended. They initially thought that the heliopause might be located near Jupiter, but as the spacecraft traveled farther, it became clear that the boundary was much more distant than originally anticipated. As Voyager 1 journeyed through the outer planets, it detected radio signals that were thought to be linked to solar flares, massive eruptions of energy from the sun. These signals, recorded at frequencies of 2 to 3 kilohertz, were too weak to be detected from Earth, but could be picked up by Voyager as it passed through the outer edges of the heliosphere. These radio waves are believed to have been generated by electrons vibrating in response to the plasma ejected by solar flares. The plasma then interacted with the heliopause, causing the vibrations that produced the radio waves. This interaction gave scientists a way to measure the distance to the heliopause, which was determined to vary between 116 and 177 astronomical units, AU. On August 25, 2012, Voyager 1 crossed the heliopause at a distance of 25 Australian dollars, officially entering interstellar space. The data sent back confirmed that Voyager had left the heliosphere as the spacecraft detected the disappearance of high-energy particles from the solar wind and an increase in cosmic rays from outside the solar system. However, not all scientists were immediately convinced of Voyager 1's crossing. One of the key instruments on Voyager 1, the plasma instrument, had stopped working earlier in the mission, preventing it from measuring the sudden increase in particle density that would confirm the transition from the heliosphere to interstellar space. Furthermore, the magnetic field data presented another puzzle. Scientists had expected the magnetic field outside the heliosphere to have a different direction from the one inside, but Voyager 1 found that the orientation of the magnetic fields was surprisingly similar. This unexpected result remains a mystery with no clear explanation for why the magnetic fields inside and outside the heliosphere are aligned. The Sun played a crucial role in this discovery as well. In early 2012, solar storms began to send shock waves through space, and by the following year, these disturbances had reached the plasma that Voyager 1 was passing through. As a result, electrons in the plasma began to oscillate, generating radio waves that Voyager 1 detected. These waves provided further confirmation that the spacecraft had entered a region of much denser plasma, a key indicator that it was now in interstellar space. 6 years later, in 2008, Voyager 2 also crossed the heliopause on November 5. This time, the spacecraft's plasma instrument was fully operational, and it recorded a significant increase in the density of charged particles such as protons and electrons, as well as a sharp rise in temperature ranging from 30,000 to 50,000 Kelvin. These readings were much higher than expected, likely because the plasma had been compressed as it entered the heliosphere. As with Voyager 1, Voyager 2 observed a decline in the solar wind and an increase in cosmic rays from outside the solar system. Interestingly, the magnetic field once again did not change in direction, confirming that the similar results seen with Voyager 1 were not an anomaly. This suggests that the magnetic fields in interstellar space may be more complex than previously thought. The relatively close proximity of the heliopause to both Voyagers also indicates that the heliosphere may be stronger and more resilient than earlier models predicted. Both Voyager 1 and Voyager 2 continue their journey beyond the heliosphere, moving farther into interstellar space. Each day, the signals they send back take more than 22 hours to reach Earth, traveling at the speed of light across the vast distance. By the end of 2023, it's expected that Voyager 2 will have traveled 29 astronomical units, AU, making it the second farthest spacecraft ever launched, just behind Voyager 1. These two probes are traveling in opposite directions, with Voyager 1 heading toward the constellation Ophiuchus and Voyager 2 moving toward the constellation Sagittarius. Despite their distance, both spacecraft continue to provide valuable data, including reports that Voyager 1 detected a hump related to waves in localized regions of gas in the otherwise empty space between stars. As the plutonium fuel that powers the Voyager probes gradually degrades, it generates less heat, which poses a challenge for the spacecraft's continued operation. NASA engineers have had to make difficult decisions, turning off non-essential systems to conserve power. This includes disabling the heaters that protect some of the scientific instruments from the extreme cold of space. Despite the lack of heat, 5 devices whose heaters were turned off in 2019 are still functioning, which has astonished scientists. The fact that these instruments are still operational at temperatures much lower than anticipated is a testament to the resilience of the Voyager spacecraft and a mystery that NASA engineers are still trying to understand. In 2022, Voyager's attitude control and articulation system, which keeps the spacecraft's antenna pointed toward Earth, experienced a malfunction. This system is crucial for maintaining communication with Earth, and when it failed, Voyager began sending back incorrect telemetry data. This error was traced back to a computer onboard that had stopped working years earlier. The malfunction confused the spacecraft and disrupted its ability to determine its orientation. Fortunately, NASA engineers were able to resolve the issue by resetting the system using an older computer, allowing the spacecraft to continue transmitting data. However, the incident raised concerns about the longevity of the mission and whether the time had come to consider retiring the Voyagers, given their advanced age and the increasing challenges they face. Despite these challenges, the Voyager mission remains viable, and many scientists are already exploring the possibility of developing successors to these groundbreaking probes. The Voyagers have exceeded all expectations, but their power source is finite. As the plutonium that powers them continues to degrade, the spacecraft will eventually be unable to generate enough heat to keep their systems running. Over time, the plutonium produces less energy each year, leading to the inevitable conclusion that the Voyagers will one day go silent. Until then, however, they will continue to send back data from the farthest reaches of space, providing humanity with a glimpse into the unknown regions beyond our solar system. Let me know what you think in the comments. If you enjoyed the video, don't forget to give it a like and subscribe for more content on space exploration, technology, and the mysteries of the universe. I'll see you in the next video.